Alright guys, here's a review of lots and lots of different vocabulary words and applications of functions. We're going to do an activity in class that looks almost identical to this, so if you're watching this video, it's going to really help you with that review activity that we're going to do in class. Okay, I'm going to go back to the beginning. Alright, so what you're going to get in class is a picture of a graph, and you're going to have a worksheet to fill out about it. So the first problem we're going to look at here is we have an angry bird is being launched. The vertical distance in feet is a function of its horizontal distance in feet. The function that models this problem is f of x equals negative 0.2x squared plus 4x. Okay, I have two graphs here. One is a graph of the actual situation, and the other is a graph of the function. The main difference being is that the function, this is generic. I can put this in my y equals and it graphs the whole parabola. The important part of this is this part right here. It's the part that shows what can actually physically happen. In other words, we can't have the angry bird going underground, and the angry bird starts on a launcher. It has a fixed starting point, okay? So this is a graph of the function, and this is a graph of the situation. So in your activity in class, you're going to have to write the letter of the graph that matches the function. That'll make more sense when you're actually in class. So we're going to skip that for now because it doesn't apply to the video. What kind of function is this? This is a quadratic function. It made a parabola shape. What is the domain of the situation? Okay, domain means what x values happen in the situation. Okay, x values start here at 0. And they end at 20 in the situation. Okay, so we can write that a couple different ways. We can write it as a compound inequality. X is between 0 and 20, 0 less than or equal to x, less than or equal to 20. Or we could write it in interval notation. Square brackets mean it can be equal to 0. Another square bracket, it can be equal to 20. And then it asks, well, what's the domain of the function? That's a different question, because then I'm looking at this graph. And in this graph, and I can only see parts of it, x can be anything. This graph is going to go down and down and down and down forever and ever and ever, and there's no limitation on x. All real x. Okay? All right, now we're getting into the range of the situation. The range, let's turn on, there we go. Range of the situation. Range means what y values are there. So my blue line goes up this high. So on that y-axis, it goes up to 20. So the range of the situation, again, we're not going underground or anything, so we're starting at 0. And we're going up to 20, and I can write that in the form of a compound inequality, or I can write it as an interval notation. Now, coincidence that these are both 20. The math just worked out that way, but it is just a coincidence. Okay. Part F, what is the range of the function? And I spelled function wrong. And I can't fix it right now. What is the range of the function? Okay, so the function itself, again, that's looking at this graph. And here again, I've got the high point here. And the blue lines, the sides of the parabola, they go down forever. This is going to go forever. So any value, I set this up to count by 5 just like this is over here. So all real y less than or equal to 20. And, whoops, too far. Okay. So all real y less than or equal to 20. The next question is, what is the y-intercept? All right, I'm looking up here in the graphs, either one. I can see the y-intercept is 0, 0. What does that mean in terms of the problem? It means that when the angry bird launches, it has traveled 0 feet both horizontally and vertically. It's where the angry bird launched from. Okay? What are the x-intercepts of the problem? Well, the problem has two x-intercepts. It has one up here at the launch and has another over here, and this represents where the angry bird landed. So when the angry bird launches, it has traveled 0. Reading the wrong one. Down further. What do they represent? The x-intercepts represent the point of launch and the point where the angry bird lands. All right. What is the maximum or minimum of the problem? And it does exist. It is 10, 20. Okay, see that maximum right here, 10 and 20. And you can also see it in the list if you turn on the table. What does it represent in the problem? It means that when the angry bird is 10 feet from the launcher, he is at his highest point of 20 feet high. Notice I didn't just say, oh, he's 20 feet high. I'm being specific. When is he 20 feet high? When he's 10 feet away from the launcher. Okay, so how would we label the axes? Okay, the x-axis, let's go back to the problem to figure this out. The vertical distance in feet is a function of, so that's telling me that the vertical distance, and I'm just going to abbreviate for right now. This is the vertical because it says vertical distance is a function of the horizontal distance. So how high something is depends on how far it's gone. So let's come back down here. And so the horizontal distance in feet is the x-axis, and the vertical distance is feet is the y-axis. All right, lastly, the pig's tower is 9. Now we're going to apply this and make some predictions here. The pig's tower is 9 feet away from the launcher and 9 feet high. Did the bird hit the obstacle, hit the tower? Or did it miss? And how do you know? Well, there's a couple different ways in this one you can figure it out. First of all, you can see it on the graph. Okay, if something is 9 feet high and 9 feet away from the launcher, here's the launcher. Okay, so this is the point, this is the tower right where the tower would be. The angry bird way overshot it. He's way too high. So he missed. You could also sub in 9 horizontal feet and see if the answer comes out at no higher than 9 feet high. Well, it comes out 19.8 feet high, so way higher than 9. So that's also not correct. Or you could type the function into your y equals, and again, we're looking for across from the 9 to be 9 or less, because that would indicate that the bird would hit. Okay? Moving on to a different problem. We have a collectible toy that was purchased and it increased in value. That's an important keyword over a period of years. The function that represents this situation is f of x equals 3 parentheses or times 1.25 to the x power. Anything to the x power is exponential. X power, exponential. Okay, again, the part A, write the letter of the graph that matches the function. That has to do with the activity in class, and we don't need it for the video. Okay, what's the domain of this situation? Well, the situation, that means our x values. Okay, what values can we talk about here in terms of x? So the graph starts at 0 on the x-axis. And even though we can't see it, this blue line would go on and on forever. So if we could see more of the graph, we would see that any and all of these values for x greater than 0 are allowed. And again, we have two notations we could use. We could write it as an inequality, all real x greater than or equal to 0, or we could write it in function or interval notation. The square bracket again means that it can equal 0. Infinity means it goes on and on forever, and we always put a round bracket around infinity. What is the domain of the function? Okay, so this graph here represents the function. Any x value. There's no limitation on x values. Okay? So our domain of the function is all real x. I can put any number I want to in place of x, and it'll be mathematically valid. It may not apply to the situation, but it'll mathematically give me an answer. What is the range of the situation? Well, if I look at the situation, my y values start at 3 and go up. Okay, so the situation, we start out at 3 and go up. What is the range? So it's all real y greater than or equal to 3, and again, you could use interval notation if you want. What is the range of the function? And again, function is spelled wrong. The range of the function, that's this graph over here. All right, now see this blue line that represents our functions, our exponential function. It is, if we read the graph backwards, it is coming down, 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 down. And to our eyeballs with the pixelation on the calculator screen, it looks like it comes right down, right onto the x-axis. However, that's not true. It does not come right down onto the x-axis. It just looks like it does. It is getting smaller and smaller and smaller and smaller and smaller. It's getting closer and closer and closer to 0, but it's never going to reach 0. Your calculator, after like 200 levels on the table, will round it to 0, but it's not 0. So my range is real y greater than 0. No equal bar. It cannot be equal to 0. Okay? What is the y-intercept? All right, so the y-intercept, we can see it on the graph. It's right here, 0, 3. What does it mean in the problem? In the problem, it means that the value of the toy started out at $3. Okay, so the main thing I want you to get out of this is that 3 is right here in the function, and 3 is the y-intercept, is the y value at the y-intercept. It's your starting value. It's how much of something you started with. Where is an asymptote for the function? An asymptote is an invisible line, and it's for the function, not the situation. It's the invisible line that the blue graph is coming down and getting close to but never touching. So it's the same thing as the x-axis. We're getting closer and closer to the x-axis. We're never touching it. So you could express it two different ways. You could express it as the line of y equals 0, or you could express it as the x-axis. That's the location of the asymptote. All right, because this is an exponential function, exponential functions have growth and decay factors. And the decay factor you pull right out of the formula, the function. It is 1.25. It is the value of your b. Okay? From that b, you can get the growth or decay rate. a rate is a percent. Okay, how do you get it? Well, B is 1 plus or minus the rate. So 1.25 was my B. If I'm going to start with the number 1 and end up with 1.25, I'm going to have to add. So that's why I use the plus sign, is because I'm getting greater than 1. So 1 plus what would give me 1.25? Well, 0.25. However, rates are expressed as percents. So we move the decimal over 2 times, stick a percent sign by it. So our rate is 25%. All right, how would we label the x-axis? Well, this is talking about the value of something over a period of years. Years is time, so the x-axis would be years. And this would be the value of the toy on this side. Okay. How much will the toy be worth in 25 years? Okay, so last time we could look at the graph and see it. Oh, 25 years. I would have to be able to see more of the graph in order to find that out. So looking at the graph, I won't be able to get my answer. So a couple choices. Number 1, you could just sub in 25 for x, or t as it happens to be. Type it in, and you get a big long decimal. But remember, this is talking about how much something is going to be worth. We're talking money. So we can't write this whole answer. Money has 2 decimal places. So we're going to look at the 3. The 3 is going to tell the 9, 4 or less, let it rest. So 794.09. The other thing you could do is that if you had typed this into your y equals, you could find the 25 level, okay, and you can see the answer right there. All right, we've got one more. Now we're talking about Teo, and he's saving money. He started out owing $24 to his parents. His job paid him $8 per hour, okay? Skipping writing the letter. Write a function. Oh my gosh, they don't give us a function this time? Nope, we have to write one. Let's skip down. What kind of function is this? This is linear. All right. Linear means f of x equals mx plus b. I need a slope and a y-intercept. So the function for here would be m of h, and I did this, you could write f of x if you wanted to. I did money in terms of hours equals 8 times the number of hours minus 24. So this time you had to write a function, and in the activity we do in class, there'll be an exponential one that you'll have to write the function for as well. All right, what is the domain of the situation? In other words, what are the x values allowed to be? Okay, so this is the situation. My x values can be greater than 0. Real x greater than or equal to 0. What is the domain of the function? That's what we're looking over here. Well, if this graph goes on in both directions, then there's no limitation on our x values, and the domain is all real x. All right, what is the range of the situation? That is our y values. In the situation, the y values start down here at negative 24. And, presumably he could work forever at his $8 an hour job. So it goes on forever. The range is all real y greater than or equal to negative 24. But what's the range of the function? Well, again, this line in the function goes on and on and on forever. So it's all real y. There's no limitation on y values. Okay, What is the rate of change? Well, that goes, we can read that right in the problem. The rate of change is anytime you're seeing the word per or each or every, that's usually a key word that you're talking about a rate of change. So that's 8. The rate of change is 8. What does it represent in the problem? It represents how much Teo is making every hour. What is the y-intercept? Well, we can see it. The y-intercept is at -24, but it also is the starting out amount. It's what we're talking about from the problem. So it's 0 to -24. What does it mean? It means that Teo started out owing his parents $24. What are the x-intercepts in the problem? So if I go back up to the graph and I look, I see the blue line intercepts the x-axis at the value of 3. Well, that means it took Teo 3 weeks to break even after paying his parents back. So if we look back at the graph, he starts out owing them $24. Then 1 week goes by and he's paid back some of his money. He doesn't owe quite so much. 2 weeks, paid back some of his money, doesn't owe much. 3 weeks, he's finally paid it all back. He's at 0. Now, all money he makes after this point, or 3 hours, not weeks. After 3 hours, now he's starting to make money that he can keep. How would you label the x-axis? Well, again, this is about time. So we're talking per hour. So we should be labeling the x-axis as hours. And the y-axis is how much money he has. How much money will Teo have after working 12 hours? Oh, is it in the graph? Nope. The graph only goes up to 9. So we're going to have to come down here, and we have a couple choices. Again, we could just type it in the calculator, 8 times 12, subbing in 12 for H. Minus 24 is 72. Or if you typed it into your y equals, you could go to the 12 level and see that it's $72. Okay. So this is the activity that you're going to be doing in groups when we start this, probably about Tuesday. So I'd recommend watching this video a few times and focus on parts of it that are hard for you. For example, this year, the ideas of domain and range have been difficult for a lot of students to understand in general. In the case of exponential functions, students have had a lot of difficulty with the decay factor versus the decay rate. So that would be something to go back and make sure you understand. Let's see, in quadratics, domain and range still. Then I think that's kind of it for quadratics, I think, for the function. All right, so we're going to probably start this activity on Tuesday, working in groups, and I hope that you have a good weekend. Again, it helps that you watch this video before the activity, so I hope you'll watch it. All right, have a great weekend. Bye.